Welcome back to my channel, Code IDX. My name is Terrence. I am a software developer who has a passion to simplify the learning path so a person like yourself can get a better understanding how different technologies work. Maybe you want to make a career change, or you are an entrepreneur who wants to be able to articulate your ideas to a developer. Either way, you come to the right place. So let's get to it. We are now at part 3 of the tutorial series, Simplifying Binary Code for Beginners. Now, before we execute any code, we have to create variables. Variables, like I said, are the lifeblood of every programming language, and those variables have to be stored in memory. What you have here is a representation of a table of memory. Notice that I have I have 0 to 99. That's 100 squares. And each one of these squares, they are called in memory slots. So all of these squares right here are what we call memory slots. And those little numbers 0 to 99, those are what we call memory addresses. Now, this is just for demonstration purposes. This is now how it is in your computer. So I'm just using this to illustrate. Now, one of the things we have to understand is that, of course, in order to write a good program, you have to have a variable. And that variable is going to point to a value. And that value is going to be what's we're going to have. It's going to be converted to a binary code. So what I want to do is let me take you over back to this table. Remember this table right here in part 2, I believe, where I break down how to convert a number into binary and binary into a number. And we use these numbers up here, this 1, 2, 4, 8, 16, 32, and 64. But how did we get those numbers? Well, remember that base 2 is how binary works. We're using the base 2 system. And what that means is we're using 2 to the nth power. So basically, when I break this down to you, I'm going to line these up for you so you can understand. Under the base 2, we have 2 to the 0 power. Well, let me get my little trusty pen out and see if this is going to work for me. So what that means is if I have 2 to the power, second power right here, then what that means is I have no 2's. That means it's 0. And if it's 0, then that means that it still has a value. And it's going to be assigned a bit. And so one of the things we have to remember that in binary code, zeros and ones, they're called binary digits. And so this is actually a byte. This is a byte right here. And like I said, one binary digit equals 1 byte. So it's not going to be 0, it's going to be 1. But then when I come over here to 2, what does that represent right there? So when I get my trusty pen out again, so here I have 2 times 1. And we know that's 2. So that's how we get the 2 up here. But now notice these numbers didn't just come out of thin air. It's no magic here because this is base 2. So 2 to the second power. And this is going to help you in your logic as we create variables and as we create loops, and pay attention to this process. So now to get to the 4 is 2 times 2 because I have 2, 2. So 2 to the second power is 2 times 2. That's how we get 4. And then that's so 4. So if it's 2 to the third power, is 2 times 2 times 2. And that's how we get to 8, all the way up to 128. Well, we know that the binary code for 0 is all zeros. So we have 8 zeros. And what that means is, in order to have 8 bits make 1 byte, this is considered 1 byte right here. And also, too, the highest number that we can go in binary is 255. So that means we have all ones inside this 8 inside this byte right here. So how did we come up with the 255? We did. Can 128 subtract from 155? Yes, that's how we have the 1, which that's on because we talked about the switches, micro switches. And so 1 represents on and 0 represents off. And all of this is true. And it also represents true and false. So we're going to be dealing with conditionals and Boolean logic. And so these all represents true. So this is all true to equal 255. So now we come back to our grid. So we know that we have a memory slot and we know that we have a memory address. Now, when we create that variable, let's say we create this num variable right here. So num is assigned to 1 or it's pointing to the number 1. Well, we know that the number 1 binary code is 0000010. That's the binary code for 1 as it's getting converted. Now, in memory, you have to understand that this whole table is called a bounded memory. Bounded memory means this is all the memory you're going to get. Our illustration here is 0 to 99. So that means we have 100 memory slots. And how this memory table works is that 1 is what we call a base 32 bits. So when we go back over here to our example inside the bits, we had 32 bits. This 32 bits is going to be 4 times 8, which gives me 32 bits. So if I have 4 times 8, which is 32 bits, in memory, I can have 4 slots. I need 4 slots to take up to make that binary code work. So this is how it's going to look in your memory on your machine. And so I'm going to put this in like here for illustration purposes. So I'm going to put that over there so you can see this. So as you can see, this takes up 4 slots because the number 1 is 32 bits. And as we get into bigger numbers, we'll get into 64 bits, and that takes up 8 memory slots. So if I needed 8 8 memory slots, then that's what's going to be allocated for this one particular number, or whatever that number is. The machine is going to allocate that many memory spots. And how this also works is they have to be in sequence. I can't, these 4 memory spots are taken up. No other binary number can occupy those slots. Only this number can occupy those slots. So if I had a variable here where I had a num2 and it had a number 56, it could not use this memory address 22, 23, and 24. I need another 4 slots to handle that. Now, you would think, wow, that's a lot of information just for 1 or 2 numbers. But your computer is big. So one of the things I want to make sure you understand here is that this is the breakdown. It takes 1,024 bytes to make 1 kilobyte. So we understand this 8 bits, this 1 byte represents 1 memory slot. So 1 memory slot has 1 byte in it. And I need 1,024 of these just to make 1 kilobyte. So just so we understand this process, now if I had 1,024 kilobytes, makes 1 megabyte. And then go further, we need 1,024 megabytes to make 1 gigabyte. Okay, do you see the pattern here? Now, this is interesting. Let's say you just bought your computer and you bought a computer that had 128 gigabytes of storage or 256 gigabytes of storage. Well, let's look at this. That means that the storage that you have in your computer, for 1 gigabyte, it stores 1,073,741,824 bytes. That's bounded memory. So if you have 128, or better yet, 256 gigs of RAM, this is how much bytes that you have in your memory. 274 billion 877,906,944. That's how many bytes you have in storage or memory access for your computer. Now, that's just for the storage. We're not even talking about RAM. Unless you are a graphic designer or you just the type of person who loves to have the latest and greatest, some of you purchase your devices or your computers based on price, not based on what it can do for you or the specs. Because, as you know, the more RAM you have, the more expensive the machine is. And a lot of times, when you don't have a need for that, you're not going to spend that kind of money. Up until this point, some of you were just novice. You were just using your computer for a word processor and just to surf the internet. That's enough to do what you need to do. But when you start running more programs that take up a lot of memory, your computer is either going to run very slow or it's not going to work properly. And so you need more RAM to be able to operate certain softwares. Well, the minimum that you're going to need as a developer, and I'm not telling you to go out and buy a new computer right now. When you get your job, they're going to give you the machine that you need, that has the specs to do your job. But as a developer writing programs, you need at least 16 gigs. Let me put it in perspective for you. I have a MacBook Pro, and my MacBook Pro has 32 gigs of RAM, and I work that machine. Also, I have a Area 51 Alienware Windows machine. Matter of fact, I'm recording on this one right now. Has 64 gigs of RAM, and that has a 4 terabyte hard drive. My Mac only has 1 terabyte of hard drive space, and so I work my machines, but I run a very strong softwares that I need that type of RAM and I need that type of memory to do the job. And right now, you may not need that much specs or that type of tool, but eventually you will. Because, like I was saying earlier, we say that 32 bytes, 32 bits, or bytes right here, or bits rather. There's 32 bits right here with these zero zeros and all these zeros and this one. That's 32 bits right there. Something else uses 32 bits, and that is what we call, and you're going to come across this. It's called I. Oh, let me get my pen tool going. All right, that's going to be I. Doesn't want to work with that, so let me do it this way. Okay, so you're going to run with IPv4. That's a P, and so that's your IP address uses IPv4, which means IP version 4. It uses 32 bits. And at the time when they created all of those IP addresses, they thought at the time that they have all the IP addresses they will ever need. But they didn't know we were going to have more devices like cell phones and tablets, and we become electronic country in the world right now that they're running out of IP addresses. So they had to go and create another version, which is called IPv6, which is IP version 6. Now I'm not going to get into that, but that right there is much bigger, and you can deal with subnetting, and that's another totally different course on that. But I just wanted to let you understand that none of this is magic. All of this works logically. So this is 32 bits. If I have 64 bits, that's when I have a really big number. I'm going to use 64 bits, especially when I'm creating apps for banks or anything that's dealing with decimals. The numbers have to be very accurate. And so understand how this works is just going to take you to the next level. I'm teaching you this now is because later I'm going to introduce you to space, time and space complexity. Understanding memory is going to help you understand time and space complexity because the faster your code is and the less space it takes up, the more efficient your code will be. And that's going to come when we start writing functions. Eventually, I'm going to show you how to refactor your functions to where they incorporate the big O notation. And stick with me. That's why it's important that you go ahead and subscribe and you click that notification bell and hit the all so you can receive all the updates. Because some of you, I will mentor you, meaning I will have coaching sessions where I will coach you and teach you how to succeed in your interview process. Because if you get a strong understanding of this just gives you more leverage when it's time for you to go for your first interview. And when you can really, when you're writing out on that whiteboard or you're solving a problem, you're able to talk through it and you'll understand what you're trying to do. Because if you can articulate to the interviewer what you're doing, that just gives you a much better chance of getting the job. So again, I hope this video was very helpful. Like I said, if you haven't watched one and two will fill in some gaps. And then I'm going to give you the simplest path to understanding how to learn programming, as well as encourage you and coach you how to get your first job. Because it's more to it than just knowing how to program. You gotta have a great personality. You have to be a good fit for the team. So I'll show you what you need to do to improve on your personality that's going to help get that job. Because if you're introvert, you're not allowing your personality to shine. And a lot of your interviews are going to be done over Teams or Skype or whatever, Google. They're not going to be in person. So you're going to have to be able to show them your personality through a video conference. So again, like this video, also comment on the video till I answer your questions. And I'm going to help build a community and you can be a part of this community as well. Okay, that's the end of this video. And I'll see you in another video when I'm going to start teaching you some what I call a prerequisites or prep work before I start teaching you the principles and the rules of JavaScript. So again, I'm going to be teaching you about data structures and I'm going to be teaching it to you through JavaScript. It's hard to find information on data structures through JavaScript where someone really breaks it down. And stick with me, I'll help you get there. Okay? See you in the next video.